Today we're looking at the difference between linear and exponential. So hopefully you've already written this box down, and mine didn't print. So if you didn't get this, go back up and write it down because it shows the full picture. But basically linear makes a straight line. That's why there's the word line there. So it makes a straight line, and it's written like this, where m is the slope, so that's the rise over the run, and b is the y-intercept. Exponential is going to curve, so it starts off really small and gets big, or it could go the other way around, starts really big and gets really small. A is the y-intercept, and b is the number that's being multiplied, so we'll talk about that a little bit later. So again, make sure you get that down so that during this next example you'll be able to easily tell which one's which. So on number 1, you should have some graph paper. If not, ask your sub to go ahead and pass it out. So you're going to graph each set of points and then determine which model, either linear or exponential, that these points form. So -5, 0. X goes first, so -5 and then up 0. Then -4 up 2. -3 up 4, and -2 up 6. So then it's asking, is it linear or exponential? Because it forms a straight line, that would be linear. Number 2, -1.5, so it's -1 up halfway, 0, 1, 1, 2, and 2, 4. So that one looks like you could make it a straight line, kind of, but it is starting to curve. You can tell because it's not going up a consistent amount, like this one only went up 0.5, this one up 1, that one up 2, so it's not consistent. So it is curving like that, which means it's exponential. So all you're doing on those is plotting the points and determining, is it linear or exponential based on, is it a straight line or curved. So you'll have a couple of those to try after the video. So now we're going to relate this to what we've been doing the rest of the chapter. We've already talked about arithmetic sequences and how they have a common difference. So remember, arithmetic, this is adding or subtracting, which is adding a negative. And you can model an arithmetic sequence with a linear function. So arithmetic patterns, adding patterns, are also linear functions. So we're going to be writing equations for data. So we have to know a couple things. M is the slope. B is the y-intercept. So it wants us to write an equation with this data plugged in here. So it's y equals, and then we have to figure out the slope, which is the pattern. So look over at the y values and figure out what it's going up by. So this is +4, +4. So that's the pattern, which is the slope. So it's 4x plus, and then the y-intercept, you might want to make a note, is always what y is when x is 0. So right here, this has to be where the graph crosses the y-axis because that's when x is 0. So it's +6. And we're going to go over that a little bit more, but that's just a quick example. Geometric, this was a multiplying pattern. Had a common ratio, the number being multiplied. So geometric sequences are exponential functions because they're getting big really fast, just like that curved line is. So again, the A is the y-intercept, which is y when x is 0. And then the B is the pattern, so the number being multiplied. So it's y equals, the A is 1, because that's what y is when x is 0, times, then we need to figure out what's being multiplied. So over in this column, sometimes fractions are hard to figure out. So if you look at the whole numbers, 1, 3, 9, you could probably tell a little bit easier what the pattern is. So this is multiplying by 3 each time. So this number is 3 to the x power. So that's very similar to the explicit formulas we've been using the last chapter. First number, which is when x is 0, that's where it starts. The pattern, and then the exponent represents all the x's. So let's try that. Example 2, which kind of function best models, so we have to figure out which one it is, either linear or exponential, and then write an equation for it. So if you look at the y column and try and figure out the pattern, I'll let you look at that for a minute. So you might think at first it's adding, like this is plus 4 or plus 0.4, but then if you look, that does not continue. So if it's not adding something, but it's getting bigger, it has to be multiplying by something. So if you can't tell, because it's decimals, which makes it a little bit harder, you might take any term, like 4.4, and divide it by the one before it. So if you do 4.4 divided by 4, you get 1.1. So that should be the pattern. So if you wanted to check it on your calculator, you could do 4 times 1.1. Okay, that worked. Then that times 1.1. Okay, that's working. And double check that you got the right pattern. So if you did, then go ahead and answer the question. Which kind of function best models the data? So if it's a multiplying pattern, that's the exponential. So there's one answer. And then we have to write an equation. So we're plugging into this. And again, the a is our starting number, so it's 4. Y equals 4 times the pattern, which is 1.1, to the x power. So make sure you get both of those answers. Number 2, so first we have to figure out the pattern here, so I'll give you a minute to look at it. So it's getting bigger. It's either adding or multiplying. So I always check adding first because that's typically easier. So this is plus 0.5, so is this, so is this. So that has to be the pattern. It's adding 0.5. And if it's an adding pattern, it's linear. So you may want to write those down if you haven't written anything about that. Exponential is multiply. Linear is adding. So then we're going to write the equation. Plug into this one because it's linear. M is the slope, which means the pattern. So that's our 0.5. And then B is the starting number. So the y when x is 0 happens to be 0.5 also. Those aren't always the same. It just happened to be. So you'll have a couple of those to try on your own in just a little bit. And we've got one more thing to do. So now we're going to kind of combine everything we just did with these word problems. So suppose you're studying frogs that live in a nearby wetland area. The data was collected by a local conservation organization, so this data. They indicate the number of frogs estimated to be living in the wetland area over a 5-year period. Determine which kind of function best models the data. Write and graph an equation. So we're going to first determine, is it linear or exponential? Then we're going to write an equation, and then we're going to graph it. So we need to check the pattern first over here. So I'll give you a minute to look at that. So if you're stuck, think about, is it getting bigger or is it getting smaller? So in this case, it's getting smaller. So we've got two options. It's either subtracting or multiplying by a fraction. So if you think about subtracting first, that's minus 60. This is not. So it has to be multiplying by a fraction. So to get from 120 to 60, if you're dividing, that'd be dividing by 2. But we have to do it in terms of multiplication, so that's times 1 over 2. The other way to do that is to take any number, so like 30, and divide it by the one before, and reduce. So either way, you should get 1/2. That's our pattern. So if it's a multiplying pattern, that is exponential. So there's one answer. Then it wanted us to write an equation. So we're plugging into this one. So A is our y value when x is 0, so the starting number was 120, times the pattern, multiplying by 1/2 to the x power. There's another answer, and then we have to graph. So we need to do our scale first. On the x-axis, that's our years, so I'm just going to go by ones here. 0, 1, 2, 3, and 4. And then on the y value, I have to make it up to 120. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 spots. So if I do 120 divided by 9, it's 13.3. So I'm going to go by 15s just to make it a little easier. So 15, 30, 45, 60, 75, 90, 105, 120. So that's high enough. And then plot each point. So 0, 120. Oh, I need to label years and population. And then it's 160, 230, 315, and 4, 7.5 would be right in the middle there. And then connect your points. And then that's all you have to do, but you could kind of double check. A curved line is what I just ended up with. Think about, does that match the answer that you just put down? Curved lines are exponential, so then that will kind of help you check that you got it right. So you'll have this one to do on your own. When you're finished with the video, you'll have the questions, and then after that, you need to raise your hand and ask for the homework and also the review. So we only have one day in class tomorrow to work on the review, but we wanted to give it to you today so that you can work on it in resource and tonight and just kind of use tomorrow to finish up. And then the test is on Thursday. So I will not be in class tomorrow either because I'm with the juniors doing the ACT prep, but I am at school. So if you need to come by and get some help after school, you can, either today or tomorrow, and I'd be glad to help you. So make sure you are prepared for your test. Me being gone will not be a very good excuse because I will be here both days after school if you need me. Have a good day.